Hey everybody, welcome to another CS302 assignment, assignment 7, and this one is going to be, I guess, a stock market selection simulation, I suppose. So we're going to implement a priority queue min heap, and we're going to essentially do a very simple person's way of trading or doing day trading on stocks. So the rule is you always buy cheap and sell high, right? So I guess we're going to be using this greedy approach and always picking the cheapest stocks and hoping those ones jump up and then we gain money. Now, I could have said that this is actually, the input was created rather randomly, where the stocks are going to be jumping around all over the place. But with today's current events, it's actually rather kind of simulates what's been really going on in the economy, how things are a little bit up and down, a little chaotic. So it's actually going to be, maybe this could be a real life simulation of how stock market is doing. So anyway, so in this program, we're going to create our custom priority queue class. And of course, using the priority queue, we're going to, allow us to quickly pick the next smallest, or sorry, next cheapest available stock that we have. So here's our priority queue class. Of course, I'll go into more details in a moment. So here's the header file that's given to you. And here is our class priority queue. I named it priority and then letter Q because there is a type in C++ called priority underscore and then the word Q, but I don't want to create ambiguities. Although this has two template types. I think the one in STL has only one. But either way, I want to make sure that there's no ambiguities. We don't accidentally use the STL priority queue because then that defeats the purpose of the assignment. So essentially going through our class, so we have this vector bin min heap. So this is going to be a binary min heap, similar to what we covered in class. And it's going to be a vector type. So again, it could have been a dynamic array. We could have had a pointer, and then we can allocate using u and then deallocate with delete. But since we are kind of past that part in the semester, I think using a vector is just fine. This is going to be a nice dynamic array structure. And every element of this vector is going to be a priority type. So every element has a key and priority. And again, we're going to really organize it by priorities. So for a min heap, remember, we want to have it where the parent element's priority value has to be less than or equal to both children priority values. So we're going to focus on a priority, and the key is only there because we want to be able to identify which stock we're going to be manipulating or working with here. So the priority is going to be, we're going to organize it by priority, essentially. So we have this array, and remember, this array is going to emulate a binary tree. So we're not going to actually create a custom binary tree object, but this array, bin min heap, is going to emulate the binary tree. Then we have this map, unordered map. We can have a T1, so our key type, to a size T index. And it's called keyToIndex. Now, I'll cover that in a little bit, but the purpose of this is we're going to be updating priority values of stocks that are currently in our priority queue. And we don't want to linear search to find a particular stock and then update it. So this map is a way to quickly find something in our priority queue. And I will do an example of this just in case if you missed that lecture on this. I'll go over what this map will be used, how it's going to be used, sorry. Then we have our bubble up and bubble down, pretty standard functions. So we pass in some index, and then we're going to bubble up from the given index. Remember how bubble up works? We always have to compute the parent index, and then compare the priorities. If the parent index is not less than or equal to the child, we have to perform a swap in our arrays. And then, of course, you have to continue this process until you finally hit the root, or once the parent is smaller. But as the same idea like in class, bubble down, same concept. We bubble down from a certain index. We pass index in. We have to compute our left and right children, and then determine the smaller child, compare it to the parent. If the parent is not smaller, we swap, and then we just move down that position. We keep bubbling down as far as possible until we have a case where we finally reached a leaf node, or once we have a case where the parent is in fact less than or equal to the children. So again, this is actually very similar to what you definitely covered in class. Nothing different there, but I will talk about the map in a little bit. So then we have our basic functions, our constructor, priority queue. All it's going to do is going to allocate a size one vector. So remember in class, we treat index 0 as a throwaway. Index 1 will be our root position. And again, it's because the math is a little bit easier, at least for me in class. It helped me with the math so I could work it out live in class and not make a mistake. So it's up to you, but I would just say, just resize your vector by 1. So index 0 will be allocated, but it'll be a wasted spot. And then from index 1 onward are going to be our elements in our priority queue. So this constructor just allocates a size 1 vector to bin min heap. So you can just do bin min heap dot resize, pass in 1. Push back, pretty basic. We want to insert a new element into our priority queue. So we pass in our key and priority value. We can create a priority type variable within pushback, insert to the back of our bin min heap vector, and then bubble up from the index of this recently inserted item. So again, pretty standard. Pop front, remember, it's going to remove the first element by taking the last element in your priority queue, overwrite the root with it, then remove that last element because now you overwrote that into the root, and then bubble down from index 1. These two getter functions right here, so get root key returns index 1, which is the root element's key field, 1 line of code. Get root priority just returns the root node's root element's priority field, 1 line of code. I'll go over update in a second. IsEmpty is also a one-liner. So the size of the bin min heap is only 1. That means it's empty because you only have that one element, index 0, which is our not used element. So if the bin min heap vector has only one element, it's empty. And then for get size, just return the size of this vector, bin min heap minus 1, because remember index 0 is not going to be actually used. So that's those functions. Update's a little bit more involved, not really quite, similar to pushback. Difference here is in this function, you're passing in a key and a new priority. So you want to find the element in the bin min heap that matches this key, and then reassign with this new priority. And then of course you have to either bubble up or bubble down this item, because you maybe this element's priority might have increased or decreased, so then it has to either bubble up or bubble down based on what's the new priority of this item. So update, you just search. And of course, you don't want to linear search through your priority queue. You want to use your map to quickly find what index is this key located, reassigns new value, and then of course either bubble up or bubble down. So that was our quick rundown of our priority key class, and there's really not much to this, but I'm going to right now just talk a little bit about this keyToIndex map right here. Then I'll go over the input and then of course the main parts of the assignment. Okay, so consider this structure right here. So the array at the very top, let me just circle this in first. This array right here, that's going to be your bin min heap vector. And notice that we have these key values that are red. The names in red will be the key. The numbers in blue will be the priority. So this is going to represent the priority queue. Now right below, this is going to be our tree. You don't have to, of course, you're not going to implement this tree at all. But sometimes we use, when we lecture in class, we use a tree sometimes to help us visualize this a little better. But you're not going to implement the tree. It's just there to help us sort of see how this is a valid priority queue. We can see that the parent is in fact its number is less than both children. In every single case, that is correct. So it is a valid bin min heap. Now let's focus our attention right here on this part of the notes, right there. That's going to be your what's it called? The keyToIndex, I believe it's called, right? Let me just double check this. Yes, so the keyToIndex map is right here. So this map is just simply taking every key in our priority queue, and then the value it maps to is going to be the index. So for example, if I were to, let's say, just put this here, right, as a different colored pen to not cause confusion. If I were to say keyToIndex, and I pass in the string, let's see, I'll just try Luigi. fit Luigi right there, barely fit that in there. This is going to return back to me 4. And 4 is the index of where Luigi is. So for example, if I wanted to update, let's erase this so it's not in the way. If I wanted to update an element in your priority queue, if I want to update, say like I want to update Luigi from 7 to 2, let's say. If I didn't have this map, I'd have to linear search this priority queue until I finally find a matching key. But we don't want to do that because we're past CS135. We don't want to be doing linear search anymore. So this map, we can pass in the key into this map. It spits out this number, and that number we can index that in our bin min heap. So in a constant time, we can find every element in our map. So for example, if I want to update, all I have to do is I want to update Luigi. So let's say for the update function, I'm passing in, let me just move down here for a second. Let's say we have our object, our priority queue object. We can do update Luigi 2. So what's going to happen is we're going to pass in Luigi and 2 into this function. Let me just scroll up a little bit. There we go. Try maybe I can zoom out so you can put it all into one frame. Okay, there we are. So we have Luigi right there. So we can pass this parameter into our map, returns 4, and take that value 4, index 4 Luigi's right there. So we found Luigi, and we want to update Luigi's number from 7 to a value 2. So we would update that to, and then we have to bubble up from index 4. Now, in this case right here, we have to update Luigi right there to be 2. We have to now bubble up Luigi. Now, when we do this, for example, remember we would swap these two elements in our array. So we would swap Luigi and Toad. Sorry, Luigi and Yoshi. We would swap these two, sorry. Now remember, whenever we have to bubble up or bubble down in our map, sorry, in our priority queue bin min heap, we also have to update our map as well. So for example, right here, we would have to swap Luigi and Yoshi. So I'm going to go ahead and put Yoshi right here. We just simply swap these. So now we have Luigi 2, and then Yoshi has the value 6 right there. So we would swap this now. I'm not going to show it in the tree, but of course these two would swap. But we also have to make sure we swap that we have now Luigi is now 2, and Yoshi is now 4. So whenever we insert, even a pushback function is going to insert into our map. Every time we have to bubble up or bubble down, whenever a swap has to happen, we have to also update our map as well. So again, the whole purpose is we can very quickly update content in our priority queue. Now, for like pushback, if I were to insert something new into my priority queue, I'd have to insert something new over here. Say I want to insert, let's say, Bowser into this. I would insert Bowser right here. Naturally, index 7 where Bowser would go. Let's say I have Bowser, let's say if I have like 1 or something. Then of course Bowser would naturally go in our tree at the very end. We have to insert Bowser into the map as well. So I'll insert Bowser, and currently Bowser is at index 7 at the moment. But of course you would then have to bubble up from index 7, which would Bowser would move all the way to the very front. So essentially, every time we insert, either push back or pop front, we have to either erase or insert into our map. Every time we swap any two elements in our priority queue bin min heap, we have to also swap the same elements in our map as well, because we want to make sure that we always have the updated map constantly. We want to be able to have all the correct indices of these keys in their respective location in the priority queue. So again, that's the point of the map, and just you have to manipulate this map every time we bubble up and a bubble down, and then push back and pop front is also going to have to update because you are either inserting something new or removing something, so the map has to also update as well. I don't want to give away too much more, but hopefully you get the idea. So now let's go ahead and look at the main part of the program, input, do a little test run, and so forth. So for the input for this program, everything will be read in using command line arguments. So here I have them listed out right here in the PDF. Let's go through them one by one. So argv1 will contain a file that contains all your stocks. So here it is. So stocks.txt, this will be passed into argv1. This just contains a list of all the stocks. So the first thing you would do in main is read this file and then push each of these stocks into your priority queue. So this will be the key type, the keys will be these strings, and then for the priority or price, just pass in 0. So you would just push back AAPL 0, MSFT 0, AMZN 0, and so forth. That's your first step. Pretty simple. Now, argv2 contains this simulation file. Let's go ahead and check out one of these. So input 3, this will be passed into argv2. And this just contains the price or the cost of each share of each stock on each day. So I believe input 3, there's actually 5 days worth of, actually I think it actually has 10, I believe. Okay, I think it has 10, or maybe it's 15. I think it's 15. It has 15, I believe. Or no, it has 10. I forgot the amount, but I have it in the handouts. It's all there. So anyway, so right here, let's say we have 15, or no, you have 10. You have 10. Okay, so we have 10 days worth of stock costs. So each day is going to be one block. That's going to be your first day cost of each stock. Then the second day, this is your updated stock price values, and so forth. So to read this file is pretty simple because every line contains a string followed by a space followed by a decimal. So very simple to parse this. And since in our stock file we know how many stocks we have in total, then we know how many lines to read. So that way we know whether we read all those stocks on each day. So since we have 18 stocks, you have to run 18 steps of this loop to read 18 lines. That's going to be your first day. The next 18 lines, second day, and so forth. So knowing the amount of stocks that we have will make it very easy for us to parse this input file. Now again, since you're using, I would imagine we use the input extraction operator, these extra lines don't really matter, but just there to help us visualize if in case you wanted to, I don't know, just there to visualize the separation of these stocks per day. So then after that, our argv3, argv4 is going to just essentially, we're passing in the amount of days you want to simulate, and argv4 will be the initial amount of money we have. So here's an example of how we run this program. Now here's the output, but for each of these I actually linked at the very top. This is how I ran this. After I compile my program, I pass in argv1 stocks, argv2 is the input file, and I passed in 9, and then that's going to be my number of days I'm going to simulate, and then the initial number 500. Now remember, for the argv array, it's going to be an array of strings. So you're going to have to convert these into integers and decimals. But luckily, we have functions a to I and stod. So we can use those functions to just return the decimal or integer version of these two strings. And of course, we simulate all these days. Now, you may wonder, wait, why is there only a number 9 days to simulate, and we have 10 days in that file? Well, it's because on the 9th day, we buy some more stocks. On the 10th day, we sell our stocks that we bought on the 9th day, and then we're done. So that's why. So on the 10th day, we're not going to buy any more stocks. We have to have the cost of each stock on the 10th day, so we can sell what we bought on the 9th day, and then we're officially done with the simulation. But again, all of the output files I did link at the very top so you know how I ran these. And of course, I'll use the same exact inputs in CodeGrade. So let's go ahead and now just go over the actual main and how we generate this output next. Then I'm going to go ahead and just quickly simulate this and compile it for you so you can see how it works. And then that should be the end of the video. So here's the output written out here as well, but of course you can probably get a better idea of the output if you check the sample output provided, but I put that there anyway into the PDF. Let's discuss the contents of main. So I have these listed out, not super straightforward, but again, it's all there. So you first want to just declare a priority queue object, string to double, because you're going to have the stock name And of course, the priority value is going to be the cost of that stock. And of course, this priority queue is going to maintain the priorities. So of course, the stock with the cheapest cost would be at the root position. If you pop that off of the priority queue, then the next smallest would make its way to the root. If you push back something, of course, you want to always focus on the actual priority values during the bubble up and bubble down phases. So anyway, you first have your priority queue. You open up your first file, which is going to be that stocks file, and you insert them all into your priority queue one by one. You want to essentially insert the name and the cost of 0 for each stock. And then, of course, you're now ready to start reading from the input file. So now you want to open up another file stream past an argv2. And of course, then the next step is you want to also look at argv3 and 4. You want to get the initial amount of money you have. You want to also know how many days you want to simulate. So of course, you also have to do that as well. I think I put that at the very end, but I mean, it would make sense to get those values right here as well. And then what you're going to do is for each day, you're going to buy stocks one after the other. So you're going to keep on getting the smallest stock available. So you're going to have to use the get root key, get root priority to get the root node's name and value. And you want to pop it off of the priority queue. And you want to insert that maybe into a map. I would use unordered map because it's a nice structure. It's very easy to insert a key value pair into it. So you want to track which stocks were bought, basically. So you keep doing this until one of two things happens. Either there are no more stocks left to buy, because you buy really one share of each stock is what's going to happen. So let's say, for example, let's look at this output 3. So you first buy this stock right here, KO, at $8.82 a share. You're going to then store this into a map. So you want to track which stocks you bought on this day. Then you want to pop it off of the priority queue. And then next smallest available stock will be the Amazon stock, valued at $11.21. You're going to go ahead and get the key and value, insert into your map, and so forth. Now, once there are no more stocks available, or once you spend 25% of your current funding, you stop. You don't want to spend more than 25% ever. So those are two stopping conditions. Now, I think there's no case where you're going to buy all the stocks in each day, but I put that there just in case because I did create these files randomly, so I wasn't sure what would happen. But just as a safety net, if let's say you have no more stocks left, then we want to stop. But anyway, that's just a safety thing. But reality, once you go 25% or over, then you're done. And that's going to be it for that day. You want to output essentially then what you want to do. So looking at this, we buy all our stocks and then we're done. Then we want to output our day. And of course, we're going to have a counter. You have day 1, day 2, day 3. So you have to maintain a counter of some sort. And on day 2, the first thing you do is you're going to read your input file. So on your second day, you're going to read this. And you're going to update every stock's price by just simply reading each line. And you want to call the update function for the priority queue to update a particular stock with a new value. And of course, you have to then bubble up or bubble down based on whether the stock's price decreased or increased from the previous day. Now, also on top of that, you also want to output all the stocks that you bought from the previous day. You want to output whether the value went up or down by an amount. Now, the order of this is based on the order they appear in this day right here. So let's say if you read this line, you first check, did I buy this stock on a previous day? How do you check that? Well, you just use the map. You check the map, you look for this string. If it's not there, then just simply update this in your priority queue. But if it is in that map, then you want to, of course, say how much the stock increased. Then you want to update your current funds that you have. And then you want to push that stock onto your priority queue. And then same thing. Next line of the input, you read that. First check, did I buy this on the previous day? Well, again, use the map. If it's in that map, you bought this, I'll put necessary information. However, it's not in the map, well, then in that case, you just simply just update this in your priority queue. And that's it. And you do this for several days, constantly updating the amounts. Here's the current funds after you sold these stocks in day 2. You buy these stocks right there. So after you bought these stocks, you've spent 25% or more of your current funds. Day 3, update all your stocks, and you want to output which ones went up and down because these are the ones that you bought. And again, the order depends on how they appear on day 3 and so forth. Now for this file, there's actually 20 days in total, but we're going to really simulate 19 days because on the 20th day is when, oh sorry, input 3 has actually 9. I keep forgetting these, I'm sorry. So input 3, we're going to simulate 9 days. But on the 10th day, we're going to just simply sell all the shares you bought on the 9th day, and then we're done. We're not going to buy any more stocks on day 10. And of course, now we have our final funds right there. And again, I provide you with the arguments right there, so you know how this file was created. And of course, this is going to be tested on CodeGrade. So let's go ahead and now just go over a sample run just in case you are wondering how to run this, and then that'll be it for the video. Okay, so as always, to compile this program, since we have our main file, and main includes priorityqueue.h, and priorityqueue.h includes priorityqueue.cpp, you have to only just compile main.cpp. Now again, for templates, it's a challenge to separate the header file from implementation file and compile, in a normal way. But the reason why I do this is because I want to have a separate header file, so that way you can't tamper with the header file at all, because on CodeGrade, it's going to link the header file to your source code. So you only have to submit just 2 files, main and priorityqueue.cpp. So just to make sure nobody modifies the class at all. Anyway, so let's compile this. Now to run this code, a.out, and our first argument will be our stocks file as always. And then I'm going to use just input 1 for now. So we have input 01.txt our second. So argv1 contains stocks. argv2 will be the input file. I'm going to simulate 1 day, and I'm going to maybe just have, I think I'll use maybe $50. It's a little different from the input file provided for you, but the idea is similar, same concept. So here's how I pass our numbers in, and then that's it. Otherwise, a space here, but maybe a mistake on my program. But anyway, there's our results. For day 1, here's our current funds. Now, of course, I can pick a different one. Maybe a better example is too simple, I think. So I'm going to try input 2. I think it's 4 days. Now I'll just pick $50. So there we go. On day 1, we have our current funds. We bought these. These are our 2 cheapest available stocks. So we first looked at our root element was WMT. We stored it into our map. We popped off the priority queue, and our next smallest one was the NVIDIA one, $35 per share. It's a pretty sweet deal right there, I think. And of course, on day 2, we just output the cost of how much our stocks went up or went down from the previous day. And the order depends on how the updates appear in our input file on day 2. The order of the stocks is a little different. So this order right here also depends on the order in which we see that stock in that file. And again, we have some increase to our funds. You buy some more stocks and so forth. Of course, I don't know why. I think I have a little mistake on mine. It has a space there. But anyway, that's the example run. Now also, I double checked this. On CodeGrade, I have it where the output checker will ignore any white space. So don't worry about having the output space perfectly. I spaced it out like this so it's easier to read the files. So when I give you the output on Canvas in those text files, you can see the output a bit more clearly. That's why I have these extra spaces, extra lines here. But don't worry about that. The output should, it's not going to be picky about the white space. I double check to make sure that that white space check is ignored by CodeGrade. And essentially, that's about it. So anyway, of course, as always, for criteria, make sure you comment your code, document, and of course, have header comments as well. And also on CodeGrade, I also have a separate test just to test out your priority queue using the simple Mario Kart simulator. And of course, then I have 7 different test inputs for the main program. So anyway, hopefully this video gave you an idea of what you need to do. So I guess happy coding, and until next time.